Welcome to the lesson on numerically calculating the value of a definite integral. If we have a function and we want to evaluate the integral from 0 to 2 of x squared plus 6x plus 9 dx, we can plug that into our calculator and have a simple equation. There are two ways to plug this in. Let's start with the shortcut method. The shortcut method uses the shortcut buttons, which are accessed through the green button or the alpha button, and all the graphing buttons, which are the F1, F2, F3. We're going to press alpha or the green button and F2. This will pull up the function options for integration. Notice number 4 says FUNINT, which is our fundamental theorem for integration. So that's what it stands for. We're going to scroll down. Or you can just choose the number 4. I'm going to scroll down to number 4 and press enter, or you could simply choose the number 4. That's sort of another short way to get to it. Once we do that, we are in pretty print, so it looks exactly like what you see on the paper. So we're just going to type in the actual function. The two limits are 0 to 2, so we need to type in 0. And then we can scroll to the right. If we scroll to the right, it'll bring us up to the upper limit, which is 2. Type in 2, we scroll to the right, and now we type in our function, which is x squared plus 6x plus 9. So we type x and then squared. The shortcut button for that is the actual x squared button. And then plus 6x, so plus 6x, and then plus 9, plus 9. The closed parentheses is already there, so I don't actually have to type that in. I'm just going to scroll to the right to get out from that function, and then we have to put in our operator, which is our X button, because you have to tell the calculator what you want to calculate, how you want to plug in the values, and we want to plug them in for X. So type the X in, and now we're ready to press enter. And that is using our fundamental theorem. The value of the definite integral is 32 2/3. 0.667 is the fraction 2/3. Another way to access the numerical derivative, the integration of a definite integral is in a different mode. Right now we're in pretty print. Let's go to mode. I'm going to change my mode to classic print. That's for those of you that don't have the pretty print. So I type mode, and I'm going to scroll down till I get to my two choices, which are math print, which is what I'm in right now, or I'm going to scroll over here to classic mode, press enter to change it, and now I'm going to quit that mode, second and mode, or that's the quit button. I'm going to use this classic print, and I'm also going to show you another way to access your calculation of a definite integral using the math button. So if you press the math button, and in the first column, it's not on the screen, but if you scroll down all the way to number 9, you'll see the same thing that we just pulled up in our shortcut. So FUNINT, which again is the fundamental theorem of integration. So I'm going to press enter to choose it. And now I need to type in 4 things. I start with my actual function, what it is I'm finding the integral of. Then I have to tell the calculator what variable. So I put a comma and then the variable that I'm using, a comma and then the lower limit of integration, a comma and the upper limit of integration. So here's what it's going to look like. Our function is x squared plus 6x plus 9. So we're going to type in x squared plus 6x plus 9. Now we don't close the parentheses. We have to continue typing, but we use a comma to separate from our next part. We have to tell the calculator what variable to use. Again, we're using x. And now another comma. We do our lower limit, which is 0, and then a comma, and our upper limit, which is 2. And now we're finished. We got to tell the calculator we're done by closing the parentheses. Press enter, and you'll see we get the exact same value, 32.667. That concludes our lesson on numerically calculating the value of a definite integral.